Hello everyone, this is Varun. In this video, I would like to explain you about coding experiment 4 Hamming code. Myself Varun Kumar and my teammate Venkatesh. This is the outline of the experiment. Firstly, we'll see how to calculate the number of redundancy bits to be added. Then we will go to how to place the redundancy bits in the code. And after that, we'll see the sample code given by NetSim. Then we'll write our own code which produces the same output. Redundancy bits. What is the purpose of the redundancy bits? We add redundancy bits for noise immunity. This is the formula for finding the number of bits to be added for error correction. This is a formula for 1 bit error only. You can see m plus r plus 1 greater than or equal to power of 2 power r. M denotes the number of message bits, r denotes the number of redundancy bits that are to be added. So from this inequality, we will take the least number of r which satisfies this inequality. Later we will see how to program this using C. So we now have the redundancy bits, number of redundancy bits to be added. But where to add these redundancy bits? The error positions, the redundancy bits positions are the powers of 2. 2 power 0, 2 power 1, 2 square, 2 cube and so on. At position number 1, you will take the parity of the series at positions 1, 3, 5, 7. At position 2, you will take the parities of 2, 3, 6, 7. You can observe like the series, how we got the series was these numbers, all the numbers in the series have the first bit 1. All the numbers in this series have their second bit 1. All the numbers in this series have their third bit 1. Now we'll just see the sample code given by NetSim. This is the user interface of NetSim. We'll go to programming. Then you will go to error correcting code, Hamming code. Normally we use even parity. So we will change the parity from odd to even. Let's say the data is A and the error position is 1. When you run, you can see the original data is the ASCII value of A. The error, as we gave the error position as 1, the last bit, at position number 1 is changed from 1 to 0. Here you can see the Hamming string with original data added redundancy bits. Redundancy bits are added at 1, 2, 4, 8, etc. The powers of 2. There is an error in the calculation of this error code, so I will not be telling you about it. You can see the value at position 2. The value is calculated by XORing these values. Position 2 is calculated by using XOR of 3, 6, 7, 10 and 11. Similarly, the rest of the bits are also calculated. So finally, he calculated the error position as 5, which is wrong because we gave the error position to be 1. You'll see the code and look into this issue. Firstly, I have written the header files and he defines the strings for everything, for Hamming code, a lot of things. Now I'll see, you can see an array high parity position of 7. He defined 1, 2, 4, 8, 16 and 32. This is the reason why the maximum 8 alphabets, because each alphabet is of 8 bits, 8, 8, 64. So the maximum number of data it can accept was 64 bits. In our code, what we'll do is we have written code for this, so there is no limit. You can send almost infinite number of data bits at a time. And he is reading input from the place we have given. You can just check through. Now we'll see our code, the code written by us. It's a simple code. Firstly, we create the standard input and output files. Firstly, I'll show you the output. Enter the number of message bits m. Let's say the number of message bits is 4, and the message is you can say all ones, 1, 1, 1 and 1. Now you can see the number of redundancy bits to be added is 3, and initially we'll just add zeros at the position of powers of 2. You can see the parities are calculated here. The parity of position number 1 is 1, and the parity at position number 2 is also 1. The parity at position 4 is also 1. So all the bits at position number 1 is replaced by 1, position number 2 is replaced by 1, similarly position 4. So the final Hamming code is this. Let's say the value of bit to be changed is 1. You can see here the new error code is 5, 6 ones and a 0. Now we'll calculate the parity after receiving from the channel. When you calculate the parities, you can check that the parity at position number 1 is 1, and at position number 2 is 0, and position number 4 is also 0. From this, you can say the error occurred at position number 1, and you can just change it to 1. Now I'll tell you how the code works. Printf prints enter the number of message bits. After that, this is the array in which message bits are stored. The loop takes the input from the console. We'll initialize the number of redundancy bits to be 0. We'll find the number of redundancy bits to be added by using this loop. This will loop through everything and gives us the value of number of redundancy bits to be added. After that, we'll just print the message bits which are supposed to be transmitted. Now we just printed out the number of redundancy bits to be printed. This is n is the total number of bits after adding redundancy bits. The B will have the final Hamming code. Mm. This is how the main function works. For in this loop, we are just copying the elements into B, so that we are appending the redundancy bits. Now we have a dummy Hamming code which has all zeros at every parity bit position. Now we'll just find the parity bits by using bit masking. We are going to find the parity using the XOR technique. As this is binary code, will have only zeros and ones. So when you XOR, you will get the same output as adding as even parity. Now the final we are printing the final Hamming code by using this loop. The value of now we are asking for the position of the bit to be changed, and we are taking it as input. If this is 0, we are changing it to 1. Otherwise, we'll make it, if this is 1, we'll make it 0. In binary, this is the only possibility of error. So the new error code becomes, and we are printing just after editing. We can just find out the position by looping through this. We are finding the parity at positions that of the redundancy bits that we added. You can see that we used bit masking I and j. If the I is a power of 2 and the same bit position is 1, then we are XORing it, and we are printing the position number so that we'll know where the error is there. Thank you.